I figured you guys might need some help with problem 1 in Quinn. This every year gives students a lot of trouble, so I thought I would address it before you had a problem. So the problem reads, the locus of points, that's the set of points satisfying a given condition, that are a given distance from a point is a circle. So he's giving an example right there of a locus of points. And he asks what would be the locus of points whose x-coordinate and y-coordinate are equal. So let's go back and look at his example first. So locus of points is the set of points that satisfy a condition. And so they have to say what the condition is. So in his example, all points that are a given distance from a point. So let's say we have this point P, and I want to find all points that are 1 inch away. So that would be that one, and let's say that one, and that one, everything that measures 1 inch away from that. And you have to find every single one of them that meets that requirement. All right, so when you do that, hopefully you start to see that you get this circle around P that has a radius of 1. Of course, I'm not drawing it with a ruler, so you can't really tell that's what it is, but that's what he means there. So the locus of points, or the set of points that satisfy a given condition, and he's specifically talking about this example, all the points that are a given distance, in our case 1 inch, away from a point P, that forms a circle. All those points right here, because they're 1 inch, consistent distance away from that point, it forms a circle. So now he's asking you to take that example that he feels is probably somewhat familiar to you, and ask you to do it again with a different condition. So he's saying, find the locus of points, and here's the condition. Your x and y coordinate have to be equal. All right, so let's think of points where their x and y coordinate are equal. So 0, 0. X is 0, y is 0. 0 equals 0. Let's do -2, -2. And 5 and 5. And -4 and -4. You don't have to stick with whole numbers. You can do fractions or decimals, but the x and the y coordinates have to be the same. So what does that look like when we plot all of them, like we plotted all these points that were 1 inch away from P? Well, let me go down here and give us a little bit more room. So 0, 0 is right there. -2, -2 would be right here. 5, 5. Trying to be neat here so it's obvious when we're done what this is. All right, here's 5, 5. -4, -4. All right, I think I might have drawn these a little bit too close together, but hopefully you see that all of these points lie on this line right here. And so what can we say about them? Well, first of all, their y-intercept is 0, 0. Right, and then the slope is from here to get to the next point on the line, which would be the next one with integer coordinates would be up 1 over 1. And then to go from there up 1 over 1, that would get us to 2, 2. Then up 1 over 1 would get us to 3, 3. Then 4, 4. Then 5, 5. So it has a y-intercept of 0 and a slope of 1. So if we were to write the equation of that, we would get y equals 1x, or just x, plus 0, which we wouldn't have to bother to write. So it's just the equation y equals x. All right, so the answer to that question, what would be the locus of points whose x coordinate and y coordinates are equal? It would just be the line y equals x. All right, I'm going to also look at ingot number 1, because that is also another your turn to play problem that you'll have to do. So there he said, what is the locus of points 3 inches away from line? Well, actually, he doesn't say line. He just says from PQ with the line over it. All right. So I'm not writing everything out. What is the locus of points that are 3 inches away from line PQ? So let's draw line PQ. I'm not even going to draw it horizontally. Let's just draw it like this. Oops, you couldn't see that. Sorry. Okay. So if I were to go 3 inches away, let's say 1, 2, 3 inches away. Again, we measure distance. If we've got a point that's 3 inches away, it's because we drop a perp and that perp is 3 inches long. Right, then I would do another one that is going to be 1, 2, 3 inches away. Then I could do another one. It would be out here. Again, if we didn't know how to measure distance of a point from a line, that would be tricky, because then maybe somebody would say, well, let me go from here and go out this direction. But we know that distance of a point from the line has to be measured by dropping a perp from the line, from the point to the line. All right, so you can see on this side, we're going to get this. And then we could have very easily just gone in this direction and said, that is 3 inches away. 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 And we would get a second line. All right, so what is the locus of points that are 3 inches away from PQ? It's two lines that are parallel to PQ. All right, one, I guess, above it and one below it, or one to the left of it, one to the right of it, but two parallel lines. And line PQ is parallel to the two of them, but it runs between the two lines. So you could just say something like two lines that are parallel to PQ. You could say two lines surrounding PQ that are parallel to PQ, but just something that indicates that you went 3 units kind of north and 3 units south, and you got a line both times. There's also, so this was number 1 in ingot. And there's also number 1 in Carvel. You're not even assigned that, but I just want you to kind of get this idea of what a locus of points is. So you're not just writing down number 1 and kind of copying it. You've at least got a couple examples. So it says, what is the locus of points equidistant from the sides of the angle PQR? So equidistant from the sides of angle PQR. So let me draw angle PQR. Okay, and we want all points that are equidistant from the sides of PQR. So it has to be something like, let's say this point right here, so that when I go down and when I go over, those look about the same. Let me do one out here. Again, I have to drop a perp right here and drop a perp right here. Those are intended to look the same size. I could do it out here. All right, so again, each of these we're saying are congruent. All right, so if I were to just draw a line through there to connect, to show that all points that are equidistant from the sides of angle PQR would fall on this line, what is it about this line? How could we describe that line? All right, that's the question for you. What is this line? And hopefully you'll remember, I think we did this theorem a long time ago, and I'm saying I know that it was a long time ago. I think that we did this theorem that says that if you're equidistant from the sides of an angle, that you're on the angle bisector. So this right here, that locus of points, or that set of points that are equidistant from the sides of an angle, those are on the angle bisector. So we would say we get the angle bisector, or that locus of points is the angle bisector of angle PQR. All right, so hopefully that clears that idea up. Again, it's just a collection of points that satisfy a property, but you have to then go through and kind of draw what they're describing and see if you can figure out what it is. Okay, hope that helps. Bye.